Just in the thing that says free blank paper. Free blank paper is awesome, right? If you've finished, you can check your work with what I'm doing up here. If you've not finished, don't look at what I'm doing. Try it on your own first. But you haven't been here, so you can totally work along with what I'm doing. Yeah. Oh, hey, great minds. just kind of give me a wave when you're done so I kind of have an idea of what percentage of people are done. Okay, about half of you. Okay. Well, that's what we're going to talk about. That's why we did this one as an example. We're reviewing, but at the same time, we're going to do something a little bit new with it. But can you rub your stomach at the same time? Now switch hands. It's a strange place, my classroom. Woo! So you were like, did I do it wrong? You can always double check at the end and say I have 4 of these, which gives me 4 times 2 is 8. Yeah, so you can say I've got 8 lone pairs. Right? And you can be like, oh, I have the right number of electrons, yay. So you check that, plus then you go and you check and you say, does oxygen have 8 electrons? Yes, it does, because it's got 2, 4, 6, 8. Yeah, you know, and then you go around and you go, oh, sulfur, does sulfur have 8 electrons? 2, 4, 6, 8. So that checking process is really valuable because it'll show you, like, if you made some dumb mistake and carbon only has 6 electrons or something, you'll catch that in the checking process. So, how are we doing? Okay, now somebody asked me, does it matter where the double bond goes? And the short answer is no. The long answer is those electrons actually move, the double bond electrons move from one place to another. So you actually have 3 equivalent structures that look like this. We've got our first one. Okay, where we have our double bond on the left. And then we have another structure, and we show a double way arrow between it because it can switch back and forth between the two, where we could have the double bond down at the bottom instead. And if you draw electrons like that, I'll be like, is that 1 electron or 2 electrons? So I'm going to erase it and draw it so it looks like 2 electrons. So if you draw them like that, you too should. Like if your electrons look like this, that's not really 2 electrons, is it? It's kind of a blob. Okay, so make sure you're distinct in showing your 2 electrons. Is there a third structure? There is. Where does our double bond go in our third structure? Goes at the left, yes. Okay, and when you are drawing resonance structures, you do have to make sure that your lone pairs also move around similarly. You don't want to have 3 lone pairs. You don't want to be like, oh, over here, I've got 3 lone pairs and a double bond, because now how many would that give this poor little oxygen here? 10, which would be a sad, sad thing. So if you move the double bond, you also have to move your lone pairs. Yes? Am I missing a lone pair for sulfur? For oxygen? Oh, you're right, I am. There. Yes. Thank you for catching that. Okay, and so when you have a double bond that could move into different places, you should recognize that there is resonance, and it goes back and forth between these different structures. The word resonance, have you ever heard like the word to resonate? Okay, and if you have a bell and it rings, it goes dong, and it's kind of going back and forth. And that's what these are doing. They're resonating back and forth between these different structures. Yes, so if you had one like this, and if it was in a section that said show any resonance structures, so that would be the instructions. Show any resonance structures. You just draw them all possible, and then you put arrows, double-headed arrows between them. So that's what the instructions would read. And you would, 1, draw all possible structures. And 2, draw double-headed arrows in between. Now, you guys don't have this in any of your handouts or anything. I am happy to make a printout of this for anyone who wants it, okay? So yeah, for sure, I can do that. So towards the end of the class, I'll make printouts for anyone who wants one. All right, let's try one on your own. Let's say that the instructions are show any resonance structures, and I would like you to draw the ion HCO2 minus. It's hydrogen and the Bible, Babel, or B-ball. I like B-ball because it's like non-denominational, right? It doesn't have like any specific thing attached to it. Pardon me? Which element should go in the middle? Which one do you think? Carbon. Why carbon? Because A, it's a single element. Hydrogen can't go in the middle. But B, because it has the ability to bond 4 times. Okay, so C will go in the middle, and you can attach the other things wherever you like. You could move if you want to. You could just move one like row behind and sit where Tiana is for today. Yeah. He's not leaving you. He's just moving one row behind. So I'm going to kind of teach my way through this because Evan's been away, and so I'll kind of do it. So if you're struggling, you can follow along. If not, just ignore me, okay? So we have 1 electron from hydrogen, 4 electrons from carbon, 2 oxygens. So 2 times 6 valence electrons gives us 12 electrons. And then our -1 charge, since electrons are negative, that means we added 1 extra electron. So we're going to put 1 extra electron there. And then we just add them up. Really? All right. Out that way. We meet at the back of the field, okay? Back of the field. Back of the field. You can be number 2. Number 2 is good enough. Number 2 is pretty good. Like almost number 1. Almost number 1. Oh my God, it was so funny this summer. My son worked at the PNE as one of the mascots. Yes. Okay, as one of the mascots for like the Unflushables campaign, which is like wastewater management. So the 2 mascots are like pee and poo. So there's like a pee and there's a little like turd emoji. Anyway, so he didn't know which one he was going to be until he like went to the job for the first time, and so we came home and we're like, "What number are you?" And he's like, "I'm number 1." What a time! Oh, and it was somebody got him. Lauren was saying they got whoever it was who did it. Now, that's just a rumor, who knows? We don't know for 100% for sure until things are verified, right? But yeah. All right, so we were forming this, and what were your instructions again? To show any resonance structure, so you can carry on from there. Yeah, you can get water. So the carbon, where does the carbon go? Carbon goes in the middle, and that's because carbon has only 4 valence electrons, so it's able to bond to the most things. So if carbon is present, we will put it in the middle always. All right. This is what we call our skeleton structure. Once we have our skeleton structure, so step 1, find the valence electrons. Step 2, skeleton structure. Step 3, what do we do in step 3? Add lone pairs until all have 8 electrons. Who are our exceptions? Hydrogen, and then B ball, B ball. Whatever you like to do. Hydrogen needs 2, beryllium needs 4, boron needs 6, aluminum needs 6. So we look at carbon. How many does carbon have? 2, 4, 6. So it needs another pair. Oxygen has only 2 electrons, so it needs 6 more electrons. So we put them in pairs on the top, the bottom, and the other side. All right, and we do the same thing with our bottom oxygen as well. What do we do after we've added all our lone pairs? Count the electrons and check with which step? 1. So we're going to count our electrons. So we look at our structure and we say we have 3 lines in the structure. Each line is 2 electrons. So that's 6. In our structure, we also have 1, 2, 3, 4, 5, 6, 7 lone pairs, non-bonding pairs. So we have 7 lone pairs. So that's 7 times 2 is 14 electrons. So that gives us a grand total of 20 electrons. That's how I like to do it because it keeps them all really tidy for me. And you'll see they are counted that way in the answer key very often. Okay, so now I look back and I compare with step 1. Are they the same? And the answer is no. How many pairs do we have too many? 1 pair too many. So what that means is that we are going to erase 1 pair, and we're going to erase it from the central atom. So if we have 1 pair too many, we're going to erase 1 pair from the central atom, and we are going to form 1 multiple bond. And then we're going to do that by turning a lone pair into a bonding pair. So I'm going to redraw my structure because I've lost it up here. It's up there somewhere. Okay, so I have an H, I have a C, I have an O, la 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 la. So that was the structure I started with. I'm now going to erase. Which pair do I want to erase? I want to erase a lone pair that is on the central atom. That's our carbon, so that's the highlighted one. So it's going to go bye-bye. Bye-bye. And at this point, how many electrons does carbon have? It only has 6 because it's got 2 in this bond, 2 in this bond, 2 in this bond, so it's only 6. It needs 8. So wouldn't it be nice if oxygen would agree and say, I don't need these all to myself, I will share them with you, carbon. So that red pair is now forming a bond. And I have my lone pairs left there, 2 lone pairs on that one, and 3 lone pairs there. And at this point, you can always go back and you can check your electrons again, right? You can say, okay, I've got, at this point now I have 4 lines, and that's 4 times 2 is 8 electrons, and I have 1, 2, 3, 4, 5 lone pairs. So that's 5 times 2 is 10 electrons. Oh, that looks much better. Now I have 18, which if I go back to step 1, what did I have in step 1? I had, oh, that's messy. I had 18. Okay, so that's how many I wanted. Let's also double check and make sure that everybody has 8. Well, does hydrogen want 8? No, hydrogen only wants 2, and a bond counts for 2, so it has 2. Now, what if we look at this carbon here? How many does it have? 2, 4, 6, 8. That looks really nice. Good. Trying to erase the highlighting. It's not working very well. All right, now back here, we look over at this oxygen here and we say, how many does it have? It has a bond and a bond and a lone pair, and a lone pair is 8. And then we look at this oxygen down here, how many does it have? It has 2, 4, 6, and a bond makes 8. Sounds like I'm counting a crib game. Anyone play crib? Excellent card game, you should learn it. Look it up, it's really easy. And it's fun and it doesn't require a lot of brains, which is one thing that I like about a game, because usually I want to play a game when I'm feeling kind of tired. All right, so here we go. We have this structure. Are we done then? No, why are we not done? Because we have another possible resonance structure. So what would we do to draw that resonance structure? We have to draw the double arrow thing. Excellent. Can I do anything with the hydrogen, or is it going to stay the same? Hydrogen's going to stay the same. You can't put a double bond on the hydrogen. That just will not work. But what we could do is we could make the double bond go here and the single bond go here. And remember, when you do that, you need to also make sure that you have how many lone pairs on this guy here? How many lone pairs on this oxygen over on the right? 1, 2, 3. How many lone pairs do we need on the blue oxygen? 2 lone pairs, because we've already got 2 bonding pairs, so we need 2 lone pairs. All right, so we have 2 resonance structures. Okie dokie. So that took more time than I had expected, but at this point, yeah, let me just take a look and see what you can do for homework. You've got your quiz on Monday. So I would like you to review, if you have not yet done it, on page 86, you can do 8, 9, 10. Those are ionic, because remember, we're going to be doing ionic as well. So page 86, number 8 to 10. And then, let's see, let's give you on page 98. What? If you've already done it, that's fine. Okay, but do go back and look at it again. If already done, look at it so you remind yourself what it looks like. Because we've been doing so many covalent bonds, you don't want to be like, oh, I've got an ionic compound and I'm trying to draw a covalent Lewis structure. Yes? And then on page 98, I would like you to do, let's see, number 21, 22, 23, 21 to 23. Number 26 to 28. And 50 52 to 54. And you panic. No, we're good. It's just 3 of them, right? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 questions to do. And remember, if that's too much, because you're like, I'm really busy this evening, I've got, this activity, or my grandmother's visiting, or whatever it is, these are in groups of 3. So you could maybe, if you only have time to do 8, 21, 26, and 52, that would be possible, or you can do 2 from each group, something like that, okay? Just make sure you're doing enough that you're feeling good about it, because when is your quiz on this stuff? Monday. And when's your test on this unit? Thursday. And we are essentially done this unit at this point. So tomorrow we will actually be starting on unit 4. Okay? So there we are. After school today is the retest if you're doing the retest. Okay? Yeah. And remember, are there retests on any of the other tests this year? No, it's just this one, special. I think because the last time I taught Chem 11, it was during the COVID year, hybrid quarter system, and I had a whole bunch of people fail this test, and I was like, we can't progress until we've redone this test, so I made 2 forms of it. So. Yeah, no, I understand. I found your other quizzes. From Monday, the quiz from Monday. So when you hear your name, okay, Christina, Manning, Yun, Gio, Alden, Jacob, Aaron, John, Amy, Chantel, Samuel, Ravina, Charlene, Stuart, Nathan, Kylie, Lauren, Stuart. I always want to say your name with a Scottish accent. I don't know why. Stuart, Angela, Tiana is not here. Ben, and Savannah's not here. Ben? Chloe, did you get your quiz back? No. Okay, I probably have the original somewhere, but there you are. There's the photocopy. Thank you. you did it what day after? So I will need to find that for you.
I did
Okay.
post it out. Going away.
Well, it went away, but you need to like cross it out. It was like 0.25 of a mark or something like that. Okay, like it's like a half a mark. A half a mark on a quiz out of 54. You'll survive, Ben. You'll survive. Yeah. Hi. Oh, it's 54.
Wait, it's 0.5, but I got 2.5 out.
Oh, where did that come from? Okay, hang on. Hang on. 54. La 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 la. There we go. Oh, here. No, hang on. That one.
Wait.
That one.
Oh. Okay.
Oh. I feel like you did well in that quiz, though, so you're probably fine. I seem to recall you did well. I made a bunch of silly ones. Yeah. All right.